governor and Porter governor that we have discussed earlier. We have determined the h, right, the governor height h for the other two governors. In this case also we will be finding the height of the governor, the h, for the Proell governor. Okay, so once again, thanks for supporting and subscribing the channel, sharing, liking. Keep doing so, keep hitting the bell button and keep sharing it, keep coming, and please subscribe. It actually motivates me. So let's get in the topic of Proell governor. Okay, so as we have seen, in the other two governors, the Watt governor doesn't have a mass, the weight of the sleeve, but in case of Porter governor we have seen the weight of the sleeve is considered. In this case also, in case of our Porter governor also, we will be having a sleeve of mass that is nothing but mg, capital Mg, and the ball weight will be nothing but your small mg, and here it will be a centrifugal force Fc, which is Fc is nothing but your m omega square r. But the ball are not in the earlier position as in the case of Porter governor. This is in the extended part. Let's suppose we can call it A dash. Okay, in the extended portion of A dash, the position of the ball is there. So let's see what will be the instantaneous center, because we are deriving the value of the expression of h, the governor height, using instantaneous center method. So if we extend this thing, taking the left hand side portion of this symmetrical governor, Proell governor, so we are extending this alpha angle, we will be getting this I. As we know, there will be the weight of the ball from this point A dash, and this point A and this point A dash. As you can see, A and A dash. Yes, so it will try to move the I point in a clockwise direction. As in this case of this thing, it will also try to move in the clockwise direction, both small mg and the capital Mg by 2. And this Fc force will try to move the instantaneous center in the anti-clockwise direction. So we can develop the equation, that is the summation of m equal to 0 if we have to make equilibrium equation of moments about the point I, the I instantaneous center. It will be Fc into the distance, that is A dash d, is equal to A dash d. Yes, next your mg, yes, mg into id, as earlier we have done. Next, capital Mg by 2 into what it will be the entire distance ib. In this derivation, we will not shift this distance to the right hand side of the equation as we have done in the Porter and the Watt case. So it will be like Fc into A dash d. Let's suppose, as we know, this id is nothing but if we divide it by a certain distance AD, since see this is alpha, this is also will be alpha, this angle IAD, and angle DAB will be beta by parallelogram, the parallel lines theory. So A dash D dash by AD, mg by id by AD plus capital Mg by 2 into ib by AD. This ib is not in the suffix, this is the ib, this is the distance actually. Okay, so if we see, let's suppose we keep this ratio as it is and put the value m omega square r into A dash D dash by AD, and it will be what if we take common, this id by AD will be nothing. See, as we know, this id by AD is nothing but your tan alpha, and ib by AD is nothing but your tan alpha plus tan beta, isn't it? So what we can do, we can write it like that: mg tan alpha plus mg by 2 into tan alpha plus tan beta, isn't it? So m omega square r into a dash by ad, mg tan alpha. In case of id by ad, you have put in this thing tan alpha. Next ib by ad, you have put in this thing tan alpha plus tan beta. So we have generated an equation. So we'll be solving the equation to find out the height of the governor. Okay. So we are coming to next page. Let me write the equation again. It was somewhat like that: AD equal to, what was it, mg tan alpha plus capital MG by 2 into tan alpha plus tan beta, isn't it? So if we do something like that, keeping this as it is, not touching, let's suppose we've taken tan alpha as common. What it will be? M plus capital M by 2. It will be 1 plus tan beta by tan alpha. In the last derivation, we have just considered this tan beta by tan alpha ratio as Q. Hope you remember this thing. If you haven't, please go through the earlier two derivation of Watt governor and Porter governor, and you'll be knowing the thing. We have taken it as Q. Okay, and suppose the let me write the left hand side of the equation, a dash d by ad. Okay, so what we can do now, we can put the value of tan alpha as r by h. Please follow the triangle, the left hand side triangle. If you can remember, this is your actually r. This was r and this was h. Okay, and this was your alpha. So if the tan alpha will be nothing but your r by h. Okay, m plus capital M by 2, 1 plus q. What we can do is that m omega square r. So you have to remember one thing: in all the three derivations of the governors, Watt, Porter and Proell, we are trying to remove at the end of the derivation the mass m and the r, the radius of the rotation of the fly balls. Okay, so in this case our r will be cancelled out. So to cancel out m, what we can do, this g by h will be there, we can take out m as common. It will be like m by 2m 1 plus q, isn't it? So what will be that? M omega square a dash by ad. So in this case our mm will be gone. So putting the value of omega square equal to 2 pi n by 60. We have the constant value of 2 pi and 60. So if we take the h into left hand side, it will be again 895 by n square. We have the rest right hand side of the equation, and we will be transferring this ratio to the right side. So it will be ad by d dash, isn't it? Okay, so we have derived the equation of h for the Proell governor. Okay, so finally we have find out the h, right, the governor height of the Proell governor. This is the expression. If you can see from the Watt governor, Proell governor through the Porter governor, in all the three governors, the expression is getting large. In this case, if we compare the Porter and the Proell, this ratio is the different part that we have newly found out. So in the next video, we will do, we'll discuss the difference. We'll make a comparison of all the three types of governor, the pendulum type of governor, that is Watt governor, Porter governor and the Proell governor, and we seeing why this has been done, why three different types of governor has come into the use. So once again, thanks for being with me. Keep supporting, keep liking, keep subscribing, keep hitting the bell button, because it inspires me, motivates me, and hope we will meet soon in the next video. Thank you.